Hello. Okay, so on this episode of Mathematics, we're going to talk about transformations. Specifically transformations from a parent function, and we're talking about functions, not transformations of shapes. Okay, so functions do something specific because we're talking about a line. And we're going to talk about quadratic functions because it's part of the quadratic lesson. And our simplest quadratic, all transformations come from a parent function, whether or not it's linear, quadratic, cubic, or quartic. All of them come from a parent function, and that's going to be the quadratic parent function is y is equal to x squared. The linear parent function is y is equal to x, and if we want to just continue talking about this linear, let me write linear parent function is going to be y is equal to x, and a quartic or a cubic would be y is equal to x cubed, and a quartic would be y is equal to x to the fourth power. Okay, now what is a transformation, you might ask? Well, it's a change to the size and position of a figure. Okay, and in this case, we're talking about a line. All right, and the form that I have graphed on here, that is the parent function of a quadratic. Y is equal to x squared. This is y is equal to x squared. And just like we talked before, we talked about what is our vertex, what is our axis of symmetry. And in this case, with the parent function, your axis of symmetry is your y-axis. So this graph, this line right along here, that is your axis of symmetry. Here, let me highlight it. And I'll make a nice little series. So that line there, that line is your axis of symmetry. Okay, for the parent function. Okay, and that, depending on what happens to our transformation, that's going to either move it or left or right, up or down, or it may not move it because our parent function goes through the vertex. So you can identify what transformation's happening by looking and identifying what's happening to our vertex. Okay, now, these points that I pointed out, our vertex is at 0, 0. That's our minimum point. In this case, it's a minimum point. And sometimes, depending on what kind of transformation happens, your minimum, when we transform that function, can now become a maximum. That's really cool, right? That's really, really cool. So, and our axis symmetry, of course, is x is equal to 0. And if I were to plug in for the value of x, if I were to say 0 or 1, if I say 1, that's going to give me 1 squared, which is 1. If I plug in 2 for x, that's going to give me 4. Okay? But now, let's talk about transformations. So let's say, for example, and we're going to talk about the vertex and all that stuff just momentarily, because I want to talk about the problems. So let's say that we have a new quadratic, a transformed quadratic, and we're going to call this, let's say this, our original parent function, let's call our original function f of x, okay? And we're going to call our transformed function g of x, because that's the new one. We've transformed it from the parent function. And we're going to say that's g of x is equal to, let's say x plus 2, and we're going to square that. Okay. So now, depending on what happens, this right here, this is the parent, this is the vertex in our original form. Okay, now I'm going to show you what happens because it's kind of neat. Because our vertex is actually going to change. That's no longer going to be our vertex when we move things around. Okay, so let's just talk about this in general. If x is 0, that's going to give me a y value of 4. Okay, so if I go up here, and let me see, that's not going to let me do it. So I'm going to have to do a different color. Let me do a different color. The other colors won't work very well. Let me do orange. Orange is good. Yep, orange is good. So I'm going to go to 0 and 1, 2, 3, 4. Okay. So I've got 0, 4. That's kind of confusing. Let's see. Because if I plug in 0, 4, well, let's see. If 1 is a value, then that gives me 9 for the x or the y value. So if x is 1, then that's going to give me 1, 2, 3, 4, 5, 6, 7, 8, 9. That's way up there. So this here, that's no longer our vertex, because if we notice, that's kind of a curve, right? We're doing something, so let's continue. Okay, and if we've got -1, then our y value is 1. If I were to plug in -1 in for x, -1 plus 2 gives me 1. 1 squared is 1. So I'm going to go over here, -1, and I'm going to go up 1. Oh, look, there's my other point. Oh, so let's see. Well, negative 2 is going to give me a y value of 0. So I'm going to go here, negative 2, and I'm going to go 0. All right. Now, if we were talking in a betting game, and unfortunately, let's see, I can move this over. Let me see, because I would like you to be able to see these values. I want to move this down a little bit. Oops. I want to give us one more row, because I want to move this up some. So let me erase that there. So I'm going to give us one more, because our vertex, the negative 2, 0 is our vertex. And I want you to be able to see that. So this is our g of x. That's equal to x plus 2, and that's squared. This is our parent function, and this is x and y. So we got negative 3. Well, when we negative 3 originally with our parent function, our y would be 9. Okay. And here now, if x is negative 3, if we're talking about in terms of this, if x is negative 3 with our transformed function, y is going to be 4. So I'm going to go over here to, whoops, 1, 2, 3, and 1, 2, 3, 4. Now, if you notice, hold on, wait, I did something wrong here. Hold on, let me find where my mistake is. I have 2, that should be, actually, sorry, negative, that should be 1, not 4. My apologies, bad math, stop, cat. She's trying to play with my pencil. Okay, when x is negative 3, that was going to give me 1. Negative 4 would give me 4. Okay, so I'm going to go over here and I'm going to go to negative 3, 1, 2, 3, and then I'm going to go up 1. Now, if we notice, this here is our symmetric pair. So that lets me know that my vertex now on my transform function is now at the point negative 2, 0, transform function, 2, 0, transformation. Vertex. Okay, and if we notice, well, if I were to go ahead and graph this, this is my axis of symmetry. So that lets me know if this is 2 units away, this is also going to be 2 units away. All right, well, let's talk about what happened to our parent function. Okay, our parent function shifted to the left 2 units. Okay, so it shifted left 2 units. Let's think about what happens and look at what we did with our parent function. It's f of x is equal to x squared. Well, we took those x values, went inside the parentheses, and then we added something to that value in order to get that new y value, okay? Remember, the x value is our input and our y value is our output. That's what we're going to get out of it. All we're doing is we're plugging it in. So it shifted to the left 2 units, not 3. So in the next video, well, let's go ahead and put it together. And then in the next video, we'll do some more examples. So putting it together, okay, when we have the quadratic form f of x, and that's equal to a times x plus, not plus, minus h, and that's squared, and then we're going to do plus k. Now, if you remember, your vertex, taking it back to vertex formula, this is in the vertex form, right? So when it's in vertex form, we can easily identify our transformation. Our vertex is at hk, okay? Well, h in this vertex form handles the horizontal shift. And if it's plus, it's going to shift it to the left. And if it's negative, it's going to shift it to the right. Okay? These are all just rules you really just need to memorize, or you can grab both and look at it that way. Your k, this is going to represent a vertical shift. Vertical shift. Now, k is just like it is. One thing you have to remember, h is an opposite what you think. So anything inside the parentheses, it's opposite. If it's positive and you think it's going to go to the right, then you know it's going to go to the left. It's that kind of mentality. But if it's outside the parentheses, the relationship is what it is. Okay. And the vertical shift, if it's positive, it's going to shift it up. And if it's negative, it's going to shift it down. Okay? Now, let's talk about this little value a there. The a value is going to, if a is negative, and let me just write negative number, then it's going to reflect it across the x-axis. So now, what was minimum now becomes maximum. And now, if the absolute value of a is greater than 1, then we have a vertical stretch. And what that means is, if we're talking about our quadratic parent function, we're just going to graph like this is just a loose graph, okay? From our parent function, it's going to become a lot more narrow. Our y values are going to become bigger. They're going to get more big in terms of our numbers. But if the absolute value of a is between 0, so 0 less than 1, okay, then it represents a vertical compression. So in terms of, if I were to graph this, and let's see, I'm going to have my parent function, really bad parent function, but that's okay. It's going to get wider depending on how small that, and it's going to look like it's getting more flat. This is going to get more narrow, and this is going to get more flat. You can also think of the words as steeper, less steep. All right. In the next video, we'll do some more examples, and we'll do some problem sets that talk about these different transformations. See you then. Have a good day.